factoring differences of squares. So we've been looking at factoring by our distributive property. We've been looking at factoring our expressions that are in ax squared plus bx plus c form. And now we're going to look at some special products. When we were multiplying, we looked at some special products that we recognized when we were multiplying with two factors, that the product would have a certain pattern to it. We're going to use those patterns to factor, to go from the product to the factors. Most of these can you factor, some of these can you factor kind of using our distributive property. You can. Some of them are going to be hard to do that, and you just want to recognize, oh, I recognize that this has a factor of such and such, and I can break it down pretty straightforward. So let's take a look at one specific special product, our differences of squares. So again, recognizing those special products can help us when we're factoring. It'll lead us to kind of a more efficient factoring. We can go through it rather quickly. So our differences of squares. If it looks like this pattern here, a squared minus b squared. So I've got two squares. So I've got a perfect square as my first term, I've got a perfect square as my second term, and I'm subtracting. So it is a difference of squares. So that's the first thing you need to recognize. Perfect square, difference, binomial. If that is the pattern that the product is looking like, then we can break it down into two factors. I'm going to have two binomials here. The first binomial is going to be the square root of the first term minus the square root of the second term. And the second binomial will be the square root of the first term plus the square root of the second term. So two binomials, one is subtraction, one is addition. We can flip those around too and do the addition first and then the subtraction. That's totally fine. So let's look at two that we may recognize and see what those factors look like. So x squared minus 81. So again, I see this as a binomial. I see x squared is a perfect square. I see 81 is also a perfect square, and I see that it's subtraction in the middle. If it's not subtraction in the middle, this does not work. So I'm going to break that up into the square root of the first term, x and x, square root of the last term, 9 and 9, and then one has a negative and one has a positive. So one is subtracting, one is adding. So x minus 9 times x plus 9. And that is our factor. We always want to check to make sure there's nothing else we can do here, and neither one of those can be broken down into factors any more than that. Again, the reason that this works is my negative 9 times my positive 9 will give me that negative 81. If this was a positive in here, that would be positive 81. I would have to do a positive times a positive. This is clearly not the factors for that type of a binomial. All right, one more, 49x squared minus 36. So again, 49x squared, that's a perfect square. 36, also a perfect square, and we have subtraction. We're looking at the difference between those squares. So I'm going to break this up into two binomials. The square root of the first one, 7x. The square root of the second term, 6. And I'm going to make one of these binomial subtraction and one of these addition. So just recognizing that pattern, we can break it up pretty straightforward. All right, as we continue our factoring, we want to make sure that we factor things completely. So just when you look at the number 100, if we say, factor that, we're going to break it up into the prime factors that when I multiply those together, I get my original product. Kind of think about like a factor tree where I want to look at each factor that I've come up with and decide, can I factor that even further? We're doing the same thing here with our polynomials. So more than one factoring method may need to be used to completely factor a polynomial. Always check to be sure polynomials are completely factored. So you don't want to say you're done until you've checked each of the factors that you have and make sure that you can't break them down any further. So let's look at a few that require a few different methods. So I've got 2y to the fourth minus 32y squared. First thing we're always going to do is look for a common factor. So of those, I can take out a 2 and a y squared. So I'm going to take 2y squared out of both of those terms, which leaves me with y squared minus 16. 2y squared monomial, I can't break that up any more than that. But I do have a binomial here. First thing I want to check with the binomial, is it a difference of squares? So it's a difference. Y squared is a perfect square. 16 is also a perfect square. So I'm going to break that up into y plus 4 times y minus 4. 2y squared, I can't do anything more with this. This, I can't do anything more with it. And this one, I also can't do anything more with it. So I'm kind of done. So there is the factorization of my original binomial. All right, let's look at another one. This one has 4 terms to it. Again, first thing to do, please check for a common factor from everything. So here I see that I can take a 3 out of each of those, and they all have an x in there, so I can take a 3x out of each term. When I take that 3x out and kind of undistribute it, I'm left with x to the third plus 2x to the x squared minus x minus 2. 3x is just going to kind of come along for the ride here. So just like I was making a factor tree, that one is kind of done. But in here, I want to see if there's anything else I can do. So I've already taken out the largest common factor that I can find. It's 4 terms. It's really the only thing I can do with 4 terms other than look for a common factor is to pair them up and see if I can take out a common factor from there. So I'm going to pair them up. Notice I put the subtraction in my second set of parentheses, so I'll leave the addition in the middle. And then I looked for, in the pairs, do I have a common factor? So x cubed plus 2x squared, I can take an x squared out, that leaves me with x plus 2. Remember what I'm hoping to accomplish here, again, is that my second set of parentheses is also an x plus 2. Well, it's negative x minus 2. If I take a negative 1 out of each of those, I'll be left with x plus 2. So taking a negative 1 out, that leaves me with x plus 2. So here is one of my binomials, x plus 2, and the other binomial is these other abandoned pieces here, x squared minus 1. So I've got 3x times x squared minus 1 times x plus 2. Again, I want to check and make sure there's nothing else I can do here. 3x, monomial, I'm done with it. This one, however, is the difference of squares. So x squared is a perfect square, 1 is a perfect square, and it's a difference. So I can break that up into x plus 1, x minus 1. And then my x plus 2, I'm kind of done with that. So this ends up being, when I've finished factoring it, I've actually ended up having 4 factors for that one. All right, and let's take a look at this last one. I've got 9d squared minus 32. Again, first thing I want to do is check for any common factors. And 9, I could do 9 and 3 here, but 32 do not have factors of 9 or 3. There's no d in common. It's a binomial. Is it a difference of squares? This is a perfect square. 9d squared is a perfect square, but 32 is not a perfect square. So none of the tools that I've tried so far are going to work on this one. So as far as this one we call it, we say that it's prime for what we're working with. Okay, so making sure that as you're going along, you're checking to be sure there's nothing else you can do with any of the factors to break them down even further.